Hello, everybody, and welcome to this week's episode of the Visual Studio Office Hours. My name is Matt Kristensen, and I will be your host for the next hour or so. And today we're going to learn about something that I think is on top of a lot of people's minds, because what happened was that exactly 1 week ago, we announced sort of the vision for Visual Studio 2022. And one of the biggest things, if not the biggest thing, that people kind of cared about was the aspect that it's going to be 64-bit. And I'm very, very excited because we're going to learn about sort of the details about the 64-bit aspect. And we're going to learn from the PM that's now the quarterback PM of Visual Studio 2022. And we're going to learn a little bit about what that is, hopefully. And that's you, Andy. Hello, my friend, and welcome.
Hey, hello.
And you are the quarterback. What does that mean? It's a first time we do this thing where we have a program manager that's a quarterback. Engineering has done it for a while, but what does it mean?
Yeah, so that's a good question. I wish I had a complete answer for you. We're all learning this. No, I think the main part of the role is to really try to make sure that the product we ship matches the customer expectations that we want, like in terms of, the quality and the experience that we're going for. So versus, obviously making sure on the engineering side that we meet dates and engineering constraints, but really focusing more on making sure we live up to that message, like the message that was in the blog that you just mentioned, making sure that we start to deliver on that. Obviously, that blog, as you kind of alluded to, was covering the whole Dev 17 wave, so a longer time period, but really put the first down payment in the first release in 17.0.
Mm-hmm. That's a really good point. So, and in the description below, you'll see a link to to that blog post. Now, I will say, anyone watching live right now, feel free to ask questions as we go along about the Visual Studio 2022 and 64-bit or Visual Studio in general. That's fine too. I hope that we can go around and kind of explore all the different aspects. But maybe we should just talk about up front here. What were the kind of things that was in that blog post? What are the kind of the key takeaways? And when it comes to 64-bit, what is the most important thing that we need to know?
Yeah, I mean, I hope actually that the most important thing for customers, like developers who are using Visual Studio, is they just see improved reliability, improved scalability. Like there shouldn't be any drastic change in terms of like the experience of Visual Studio. Like obviously the UI isn't changing as part of 64-bit, nor are the sort of things you can do. So I know some people have asked, like, will I still be able to build 32-bit applications and things like that? And that's not changing. That's all the same. The same applications you can build today the sort of applications you can build on Visual Studio 64-bit. So for people who have used Visual Studio for a long time and have used it in perhaps complex or large solutions, they might have noticed in the past that Visual Studio has crashed, it's ran out of memory, reaching that limit in 32-bit, and so that's the sort of thing you'll see go away. There's still other reasons, to be fair, that Visual Studio can crash, plenty of reasons. So that's not going to be a magic bullet that solves everything. In fact, just to think about resources, it's not the only resources you can run out of memory. So hopefully we'll see more reliability, especially when you're using it for days on end, and you're using Visual Studio and a small memory leak or a small incremental cost of using features like a design surface grows over time, then you can use it for a much longer period of time than what you would have before hitting that bounds. And also for, some of the biggest projects today, like if you take some projects like open source things like Chromium, for example, where they have gigabyte symbol files and other large things, those sort of things will scale much better inside Visual Studio. As I think someone just mentioned in the chat, the biggest difference really is if you're an extension author. I think you talked a bit about this quite a bit on Friday in your last stream. But as an extension author, obviously your code, if it loads inside that dev-env process, will also now have to be 64-bit compatible.
Yeah. So okay, so that's kind of the broad strokes here, right?
Yeah.
And if we dig a little bit deeper, we've had a bunch of things already that run 64-bit, but they don't run in the main process, the dev.exe process. They run out of proc, and there's the C++ debugger, if I'm not mistaken, and other things.
That's it. Yeah.
Are they still going to run out of process 64?
Yep. So this hasn't changed. Like, I think people have used the word constellation. Like Visual Studio is a constellation of processes. It's not a single process. Like you mentioned, some parts of the debugger run out of process. The language service runs out of process. MS Build, obviously. So there's a bunch of things that already were 64-bit, and they continue to integrate with Visual Studio. And those processes can also even choose their own framework version. So if they want to move to .NET 6 or something, that's a possibility for them. Because they're independent things and they can be reused. And some of those components are shared with like VS Code, for example, or in other situations. So those things continue to play an important part. And it's really useful to have those out-of-process services because, setting aside memory as an issue, just having your own process means you can't essentially cause as much trouble for the main process. Your language service could potentially go down and VS can stay up and the language service can restart. Without taking down all of VS or causing an otherwise, not so great experience.
Yeah, so having this orchestration of external processes might be beneficial for other than just being able to scale to 64-bit. We can make Visual Studio more reliable. Does that mean if there would be a failure in one of those external processes, then Visual Studio, like Dev and Vexy, can kind of just respawn it, and so the user might not even notice that something went wrong, and so self-healing is kind of built into this architecture?
It depends on what the process is doing and how stateless it is, in terms of, hey, does it need to persist data across a session, etc. But yeah, that's certainly a possibility that people could design with. I think, and some of them do, but some, like say, for example, the profiler also, does some processing out of process, and it reports, if it fails, it does fail, but it doesn't impact Visual Studio. Like you'll get a failure for the profiler, but you can just try it again. Yeah, but Visual Studio is still there.
Okay. So, of course, we've gotten a bunch of questions in that blog post and on Twitter and elsewhere since the announcement a week ago. Yeah. And so one of the big ones is, and we mentioned this kind of briefly, actually, but we mentioned it in the blog post, and that's about performance. Yeah. Is there any performance-related benefits of going to 64-bit?
So we certainly hope so, for two big reasons. One is the .NET garbage collector itself. So one of the challenges with any .NET application, as I'm sure many people on the call are aware, that the memory can be, like, especially the garbage collector from .NET, obviously when it comes to collect items, it causes pauses, as it blocks threads and continues on. And so, that can be a big source. And the more pressure you put on memory, the more active the garbage collector is going to be. So in a big application like Visual Studio, we hope to alleviate some of that pressure, simply because there's more space and there's less need for the GC to do it. Also, thinking ahead, 64-bit, it's kind of been the expected environment for many applications for some time now. And so there's some optimizations that were even made for 64-bit. But looking ahead, that's definitely, the chipset, the architecture of the future, and has been for a while now. So hopefully improvements there will benefit us in the long run.
Yeah. Are there any scenarios? So you mentioned already that some designer surfaces. And so, I mean, when you say designers, you mean like the WinForms and WPF designers, right?
Yeah, exactly.
Are they typical scenarios where people kind of would see a performance benefit if they run them for like days on end?
So the biggest ones, first is initial load, because there's a lot of stuff that happens on load and there's a lot of GC. So hopefully we'll get a win there. But that's, again, we don't have great data on this at the moment because we're still in the process of getting there. But the designer scenario is actually not really immediately performance. It's more like, hey, I've used this designer continuously for 3 days, and every time I add a button, it takes an extra kilobyte of memory, or whatever. That's not the actual number, obviously, and so you just got more room to do that. Because by design, those designers obviously leak some information. Well, not leak, they require additional information the more things you add, and so the longer you work, the more memory you're going to consume. And they're in proc, not all of them, to be fair. There's a variety mix there. So that's really more on the reliability front than performance. The immediate performance, hopefully, and this is more of a fingers crossed, is a reduction in the not responding, pauses on the UI thread caused by the GC. But fingers crossed,
Is that what causes that?
Not all of them, not by a long shot. Okay. So, but it's certainly responsible for some of them.
Yeah. Okay, so that's all really good stuff that we were kind of stuff we can say that we were getting for free, right? Switching to 64-bit. So why didn't we do it before? Why wait till now?
Yeah, I mean, I think there's lots of good reasons. I mean, Firstly, and obviously, we have a large community of extension authors who are currently 32-bit, and moving them across is not, a straightforward and easy process. And many people love the extensions they have with Visual Studio, and that's a huge key part of their workload. So moving with them is really important. The other thing, is that I think when we really started considering 64-bit, which to be fair is, I was about to say before my time, that maybe not, the world, the trade-off wasn't quite the same. If you were talking 10 years ago, the prevalence of 64-bit chips and 64-bit hardware and, the memory to take advantage of that wasn't there. Whereas clearly it is now. We have a very small percentage, but we do have a percentage of customers who are still on 32-bit CPUs, who need a hardware upgrade to be able to take this. And that's changed over time. We have customers now that we've seen memory increase, the installed RAM essentially on hardware and developer boxes to really take advantage of this. So that's great. So there's a combination of both, the time is right in terms of where the customers are, and also now I think it's a much easier place to migrate, for extension authors, and also to be honest, we've also seen that over time as Visual Studio has grown in capabilities, it's using more memory. So the demand for memory as well as the supply is increasing. So this is a really combination of all those factors to make this the right time to move ahead.
Okay, that makes total sense for me. I remember we had a blog post back in the day on the old blogging platform about
from Rico.
What? Sorry?
The blog from Rico Mariani.
Exactly. Where why is it that it's not necessarily beneficial to go from a 32-bit to a 64-bit? Because the pointer size is double. We are going to use more memory. We knew all that, and at that time, people didn't have 16 or 32 or 64 gigs of RAM like they do today. It's kind of I don't know how normal it is. Do you know?
I'm trying to think of the data off the top of my head. I want to say 8, something like 90. The 95th percentile might be 8 gigs or something like that of our customer base. Some number around there. It's a lot.
At least 8 gigs.
At least, yeah. I don't quote me on that number off the top of my head, but it's quite a lot.
Yeah. So do we know then what the system requirements are going to be? Because I think today we're saying for Visual Studio 2019, I don't remember exactly, but I think we say you need a minimum of 2 gigs of memory on the system.
I don't know if we're going to,
There's a minimum requirement, and then there's what we recommend. And I think minimum 2, recommended 4. Do we know if that's going to change?
We don't. I think that's the sort of thing we're going to evaluate when we get closer in terms of knowing what those requirements really are and what those scenarios are for customers and where the performance trade-offs are.
Right. So this might be a good time to just remind people that we're kind of taking this journey with the viewers and all the customers and users out there, right? Because we're learning this as we're going along, and we want to make sure that we keep everyone up to date so you know the progress. But we don't know yet what the characteristics of Visual Studio 2022 are going to be on a 64-bit architecture. Is that right?
Yeah, it's going to take it obviously for 32-bit VS, we've had optimizations and used things like PGO and other stuff. Got years of optimizations in it. So I think just getting to the point where we have a great understanding is going to be a while. Yeah. And 17 hours is a journey. So the first preview we ship is going to be rough. I wouldn't expect all the features you'd even see in Dev 16 to make it to the first preview. Fingers crossed, but there's just so much, and it's going to be a journey all the way to release.
Yeah. And it's fun to think about because, I think it's incredible that there was no leak about 2022 was going to be 64-bit, because we've known for quite a while, and the work has gone on for even longer maybe than we knew, and so it's kind of fascinating that we've been able to keep a lid on it. And I can see from the comments that the blog post got that people were very excited and surprised. So I think that's just fantastic. Now we get some comments here. Let's get to a few of them. Someone is asking, or a few people are asking, whether when you debug your app, let's say a .NET application, the debugger now runs 64-bit, whereas before it ran 32-bit. Does that mean that you need to recompile my code, or how does that work?
No, so the debugging and all those and build tools and everything will still support both targets. In fact, today obviously you can support ARM with remote debugging and other things. So the capabilities of your app, the architecture your app uses, is completely separate from Visual Studio's. today, for what it's worth, like, the VS is 32-bit and it often debugs a 64-bit process. That's very common. And the reverse is going to be true, I'd imagine, in the future, since like classic .NET framework apps, their default is 32-bit, whereas .NET Core defaults to 64. So, there's still going to be this cross-bitness issue. And like I said, for remote scenarios, it's, we debug ARM and other chipsets. So,
and we can do that from whatever architecture we're on, like Visual Studio is running under. Doesn't matter.
Yeah, for remote. Yeah.
Could that means that the let's say the .NET debugger that's now running in proc in dev and vexy, could we take that and move out into something that runs on .NET 6 in a separate process, and it would be able to debug the same type of applications as it does today?
I mean, it depends on the scenario. Parts of the debugger probably would move to a different version of .NET. I mean, clearly the parts of the debugger even are shared with VS Code, and those components do run in different versions of .NET, and they support like the latest. They support ARM for VS Code, for example. That was just added a couple of days ago, I would say. So there's definitely the capability for that. Again, it's up to each component, each team really to figure out what's best for their scenario, and like sharing is part of that. Like if they need to share across VS Code, VS for Mac, and VS, then clearly running in like classic framework is not a great option.
Right. Let's get back to that, but before we do so, Anas, he says it's 2021. Let's just skip 32-bit entirely. Is that a good idea? Should we default our apps to run 64-bit now? Is that
wow? So firstly, you should really make this decision yourself in your application. There's no possible way to give advice for everybody, because to be fair to 32-bit, like Mads mentioned some limitations of 64-bit. It obviously is bigger, and in some scenarios, like as Rico pointed out in his blog, like if you're doing a straight up like bubble sort for some reason, then 64-bit will might well lose. But those sort of scenarios aren't super relevant to a lot of people, so it really depends. If I think the simplest rule of thumb, if you're running out of memory, then yes.
Okay.
That's probably the simplest.
So today, when you create a new .NET app, and I think regardless of console app or even Visual Studio extension, any type of .NET app, it defaults to any CPU architecture, right? In your compiler configuration.
Yep.
Do you know if there's any plans by the .NET team or any others to change that to default to, let's say, 64-bit?
I don't know. I wouldn't think so, because that ME CPU I think will run as the host OS, which Windows these days is typically 64.
Yeah, and I don't know, like if you build an app for like non-developer end users, is the norm then 64-bit to the same extent as with developers? Maybe not, right?
Right. If, for example, you're building a kiosk app that works in kiosks that were built a while ago and use 32-bit, then clearly that's not an option.
Right.
So it really is up to you to figure out what's best for your scenario, and the only way to do that is with data. And
so this past Friday, I showed some stuff we have another show here on YouTube and Twitch about writing extensions for Visual Studio. And we looked at like some of the things you need to do to support 64-bit from an extension. But of course, not everyone watched that. But if you're using extensions or if you're writing extensions, what are sort of the main things that, the challenges for extensions to bring them on board into Visual Studio 2022 and beyond?
Yeah, so I can use this as like an escape, but it depends on your code. The reality is that the more code that you have that is dependent on a specific bitness. So, for example, if you're using C++ and do lots of pointer math for some reason, then that's obviously going to be, or you write assembly code, that's going to be hugely impacted. For .NET, the challenge isn't so much the migration to 64-bit as itself, but unfortunately, one of the changes of moving to 64-bit is it turns out that Visual Studio, having been 32-bit for so long, has lots of assumptions around being a 32-bit process, and several APIs make assumptions that will no longer be true. So a classic example is they use the wrong kind of, they use a sort of pointer that's safe in 32 bits, just like pass an int or something, like a uint, and then in 64-bit, that can get truncated. And so if it gets truncated, of course, Windows behave in some undeterministic way. It could crash, have some sort of AV. A window might be drawn in the wrong location. Who knows? It really depends on the API. Then the fix for those, unfortunately, is to change the type of the parameter passed in from something like a uint to an int pointer or something else like that, so that the COM marshalling can work correctly, and everything in the system can understand that this is a 64-bit pointer. And so those APIs, like I said, Visual Studio VS has been 32-bit for a very long time, and so there's quite a few APIs that are impacted by this. And for an extension author, that's the biggest change. Isn't the flip from 64-bit, because it's kind of rare to have like 64, x86 specific code in a .NET process. A lot of people compile to any CPU, obviously, but those APIs are changing, and that's the expensive part. Is that that many of the extensions to get a lot of value out of Visual Studio need to interact with native components, and those native components have changed. They have different signatures to properly support interop.
Yeah. So that means, like, for extenders out there, they can .NET, they can continue to compile for any CPU. No change there. That's not the, or do
That's
they
not
have
the problem.
They don't have to compile specifically 64-bit or ARM64.
They don't have to. You can, but they don't have to. And so if you on the change is more around those APIs, where today, if you're to call some APIs from Visual Studio in Dev 16 as 32-bit, you need a different signature to call the same API in Dev 17 to stop. Because the decision we made, and this is impact our extension authors most of all, was that we wanted to move runtime errors to build time errors. So obviously we could have allowed this, and you could have done some lot of checking and testing and stuff, and we could have provided like new interfaces for different version, like use conversion rules, provided 2 interface or an EX or whatever. But to break it at compile time makes it super easy to fix. Like, most of these are mechanical changes, like uint to int pointer, etc. And build time, then you don't have to worry about like, oh, I never actually tested this, and the pointer was assigned in somewhere in the 32 to 64-bit range. So like, oh, it worked fine on my machine, but that was just because you never had something assigned in that higher range. And so by making it these changes at the API level for extension authors, hopefully make it much easier to find and fix.
That makes good sense. So I hope that answers the question for the various different questions. There were quite a few questions here around extensions, and of course, people use extensions. Like, there's millions of people using Visual Studio, and big percentage of those use extensions. And of course, the goal is that we're going to have all your favorite extensions available by the time that we ship the first release of Visual Studio 2022. Not the first preview, because the extenders need to get their hands on the preview before they can start porting. You can't you can't update your extension from Visual Studio 2019 to add the support for 2022, right? You can only do that from 2022.
Yeah. And in general, I think we'd always recommend you test the version of Visual Studio you're targeting. Like, it's a bit much to say, hey, it works on Dev 16, therefore it works on Dev 15. You probably wanted to test that. Yeah.
Okay. And the good news is the preview, they're always free. You can get whatever Enterprise Pro or Community and use them as much as you want. That's true, right? For extenders and people who want to kick the tires and see what's up.
So for the 17.0 preview, it's a free trial edition, and everyone will be able to try it. Though normally, to be fair, in previews you use your own licensing, so whatever licensing you've got.
Okay. Oh, so let's say you have a community license, which means you don't need a license, or you have a pro subscription. You can't just take the enterprise, or if you download the enterprise, it becomes like a trial mode that expires or something.
So I think the easiest way to think of for Dev 17, for at least the for the previews, we are planning to allow anybody to try any version.
Yeah. Okay. Excellent. Okay, here. So let's talk about .NET.
Yeah.
And .NET 4.72, which is what Visual Studio 2019 is compiled against. What about 2022? Is that compiled against 4.8 or .NET 5 or 6?
Yeah, so at the very high level, I don't think we actually announced if it's 4.7.2 or 4.8, for example, but it is definitely going to be on framework. The framework that we're currently using are not .NET 6 and .NET Core, and really, again, going back to like extension authors, hopefully that'll make the migration path much easier, because they won't have to deal with another breaking set of changes from the type defs, differences and API differences in .NET Core. .NET 6. So the big change there, and also, frankly, from our own perspective, it's nicer to break one thing at a time, like such a big change, to absorb that and carry that out, and then think of the future, and what we do in the future with different versions of the runtime. And as we said before, individual tools and components of Visual Studio, especially those running in different processes, can choose whatever thing they want to run.
Yeah,
and some of them will certainly be in .NET Core and .NET 6.
So that's a really good point. Like if we break too many things at the same time, what about stability, reliability, quality? Can we ensure that if we break everything? Like 64-bit was a big architectural change. I have a feeling that going from .NET full framework to .NET 5, 6, 7, 8, whatever the future holds, is going to be even bigger. Is that right?
It could be, yeah. Like I think that's another thing that I think we need to spend more time investigating stuff. But obviously the types and APIs are different and things like that. And there's just a lot of Visual Studio. There's a lot of code in there.
Yeah. And a lot of it is Windows specific, right? That only exists. Those APIs only exist on the .NET full framework, and not
correct. That's a big challenge. Like it's also interesting to think that the Visual Studio is, obviously we use WPF, but we practically use every type of UI framework that has ever existed. I'm pretty sure at some point we hosted a web control to host Silverlight to run a video. Or not do that anymore, obviously. So like there's native components, lots of classic Windows rendering, just regular HWinds 132 UI that's still part of Visual Studio. So it's not a monolithic .NET app. Like hopefully most of our customers have just an app .NET, but Visual Studio has a lot of native code.
So we would have to port all that to now run .NET, let's say .NET 6, and it replaced the entire UI stack as well.
I'm not too sure, to be honest. I think some of the interoperability stories do allow for some code reuse, and that's kind of the thing that has to be figured out. That is like the key thing of like, hey, figuring out how the code would move forward essentially and still work, frankly, as a native Windows app.
But that's kind of interesting because that was one of the questions that came up again and again and again, and I see it here in the comments as well, is once Visual Studio, and this is theoretical, of course, once Visual Studio moves to .NET 6, let's say, does it then become cross-platform? Because you're still talking about like some interrupts and Windows only, but why not run on ARM64? Why not run on an iPad, right? Why not run on Linux? What stops us at that point?
It's worth remembering, like kind of like saying that a lot of VS is still, even if you moved it to .NET and the new WinForms, essentially, like the cross, the .NET 6 WinForms, that's still Windows specific. Like it's only if you move all of your UI stack to an alternative, if that is Maui or whatever the alternative you'd want to use is, so that it's not true that you just take your classic WinForms app today, move it to .NET, and then that's 6, and then it works cross-plat. That's just the UI stuff, and let alone all the integration points. Like clearly Visual Studio integrates with the OS if that's trivial stuff, like a task manager, jump list, to more complex stuff like how it collects profiling data and things like that. Then there's still lots of integration pieces with the OS that are leveraged today. I mean, obviously it's just code; all those things can change, but it's not as a simple task as it might seem.
Right. I can imagine just like from a UI perspective alone, like if we were to replace all the different UI stacks today with like, let's say .NET MAUI, like that would be such a huge undertaking, and that's not enough, right? There's also the COM legacy, like Visual Studio is powered by COM to a large extent. That has to go as well. So it's
there's and even the other stuff. There's a lot of UI in Visual that's HTML and JavaScript hosted inside IE today, like using WebOC control, and that would have to move obviously because there's not really a cross-platform IE anywhere. Thank God. So like there's lots of things that would have to move. Like I think that if this was to happen, it'd be incremental. Like there's no way you'd make all these changes in a short period of time, because it would literally be throwing everything up in the air and hope you catch it all. So it's much more likely to be incremental.
Yeah, that makes good sense. That makes really good sense. Okay, so 64-bit performance. A lot of people here are asking about the whole .NET 5 and 6. But what we can talk about there, and there's been some confusion, is we've said that you can do, we're already like in Visual Studio 2019, you can do .NET 5. And in in Visual Studio 2022, you can do both .NET 5 and .NET 6. Is that right?
I think in the blog we just talked about .NET 6, to be honest. I'm not too sure about .NET 5.
Okay, so but we know we can do .NET 6 for sure.
Yeah. And the SDK is obviously very clear for .NET support different versions. Like the SDK version you use is independent of the version of the runtime you target. So it's very easy to conflate those two, but they are separate.
Yeah. Okay. I'm just skimming through the comments here. It's really hard this time because there's so many. I don't think we've had this many comments and questions.
Oh yeah, chance to. So iPad OS, another challenge with cross-platform is just that all the native, like an iPad obviously is touch first, and VS would be terrible in an iPad. So there's also those design elements of integration with the OS to consider. Every cross-platform app has to think about. Is obsolete.
Minimum requirements. We talked about that. We don't know yet, and we'll. So I will say, keep an eye on the blog. Let me see if I can find a link to the blog here. I'm just going to put that on there. So make sure you keep an eye on the blog because that's where we're going to update every time we know and we have something to announce and we know more answers to these questions. We're gonna blog about it. So make sure to bookmark that if you don't already. Yeah. I will also say that if you like content like what we're doing right now, talking about the inner workings of Visual Studio, then make sure to hit that subscribe button below, okay?
And to some people's point about moving to .NET 5 and 6 in terms of memory and perf improvements, which obviously, those versions don't have huge amounts over the framework. Yeah, we'd all love to get there. I don't think anyone's making an argument for not going there. I think it's a case of how and when. And I think, our approach will be incremental, moving components, as, needed essentially. Rather than everything at once. It's also worth keeping in mind that VS is built also a bit like a constellation of things. It's not all one monolith. Teams deliver components into multiple places at once and are on different schedules and stuff like that. So it's not a big switch.
So here's a question: what about backwards compatibility? So the way I understand this is if you create an app, a project in 2022, can you open that in 2019 and vice versa?
Yeah, so with every version of Visual Studio, asset backward compatibility, the ability to bring source code, project files, solution files, etc., forward, is a huge part of what we want to happen for customers. It shouldn't be the case that updating VS, all of a sudden breaks all your stuff. There is a problem. And those challenges vary from simple stuff like, hey, the latest version of VS brought the latest version of the the C++ runtime and the Windows SDK, and those versions contain breaking changes from your previous version. So firstly, some of those things are side by side, so you should definitely install that. In general, though, we want to make sure assets move forward as much as possible. I'm sure there's going to be some special cases where that's not the case. But there is side-by-side Visual Studio, obviously, and many of the things that traditionally have not been have been a source of this. Frankly, the C++ compiler toolset is a common one of these, are side-by-side compatible, and so you need to tick that extra box of if you're using the 140 version of the C++ toolset, but VS defaults to 142 because it's the latest, etc.
Yeah, that's a really big difference this time around, right? Where the Visual Studio, the C++ compiler is now binary compatible. The runtime is binary compatible with previous versions.
Yeah, so there is that, and the C++ team should talk exactly about how the CRT magic there. And another point to mention, actually, if you do have these challenges where moving Visual Studio forward is not moving forward the SDKs or other things your application depends upon, you can create what's called a .vsconfig file. And you add that to your repo, and then if Visual Studio sees it and sees you don't have a component installed, it will tell the user with a gold bar, hey, you need to install some extra stuff.
Oh, so, pro tip. Yeah. Pro tip right here, everybody. And you can go out there and search for it. It's just
you have to Google this quickly.
Yeah, Google vsconfig, right? .vsconfig is the file name. I think there's a blog post that I don't know if you wrote that, but kind of maybe a year ago.
Okay. But yeah, and you can export them from the installer. If you go to the more drop down, you export them, and that creates this .vsconfig file. And so that tells what is currently installed. And the idea being, hey, if it currently works, then all gravy.
So that basically means you can take a snapshot of the required components of Visual Studio and create a file called vsconfig, which is just a JSON file that has a list of the components that Visual Studio need. Check that file into your repo, in the root of your repo, and when you open that in Visual Studio will check that file, make sure that all the components are installed, and if not, prompt you to install them, right?
Yeah.
Did I do that right?
There is still some work we're trying to figure out with versioning, because that certainly works for component IDs and things. But I think, and I'm pretty sure that the SDKs include the version in their ID. I don't want to stand by that, but I'm fairly sure. So that means you can use it in that scenario, because the idea, yeah.
All right. Here's one. I don't know if we can answer it, but I think we should at least acknowledge the question because we gotten it quite a bit. When is Visual Studio 2022 going to be released? Andy,
That's a good
we
question.
demand answers.
You tell us. No, like I think it's in the blog. We're aiming for a summer for a preview, and then this is going to be a journey. Like, to be honest, I'm not. We have dates in mind, but they're not set in stone. And I think it's going to be a learning journey. One of the challenges is going to be moving extensions forward and making sure all the components and features in VS have been tested at 64-bit, and that quality is at the right place and the performance is at the right place. So hopefully, we honestly don't have a concrete date to share other than it's not particularly concrete, but summer for the preview, and then it's going to be a journey. Like I said, not everything will be there from day one, especially perhaps performance and things like that, and they'll come as we work on it and we get feedback from the community and from people using it.
Yeah, and you're mentioning extensions, but I don't know if a lot of people are aware of this, but a lot of the features that we build internally, the Visual Studio team built, they're extension as well. We just package them differently inside Visual Studio, but they're using the exact same SDKs and they code against the same APIs and so on. So I assume there's a lot of internal code churn that has to happen as well as we discover more. Like those internal extensions, those features have to be has to evolve as well.
Yeah.
And hopefully we can take the learning from all that, publish it out to the extenders so they can get that learning and that'll boost everybody getting to 64-bit as pain-free as possible.
Yeah. Just looking at the comments. So one comment, I guess, so someone asked, why Visual Studio 32-bit is limited to 4 gig of memory? So that's just simple mathematics in the sense that 32-bit pointers can only have so many unique combinations, addresses, and that limit is 4 gig essentially.
Yeah.
And it's even more complicated on Windows because technically Windows splits it 2 and 2 between user mode and kernel mode, but they've kind of shifted that a bit, and you can specifically require more up to like 3.7 gig, I think is the current limit. The rest is kernel space.
Yeah, I never kind of understood that. So what is the actual, not theoretical, what is the actual physical ceiling of how much memory can Visual Studio use on a machine that has, let's say, 64 gigs of RAM available? When does it run out of memory today?
So the RAM usage of memory is obviously virtualized these days. It's not limited to the actual physical memory. So each process will get a unique range. And how that's mapped, it depends on the OS, but in Windows, it's mapped with something called paging essentially, where Windows will say hey, I've got 8 gig of memory installed, like hardware, physical RAM, but all my applications are consuming, God knows how many gigabytes, and they'll allocate some of it to basically go to the hard disk or somewhere else. And so, it's not like you can only use so much; it's all virtualized. But within that allocation in your own process, you're limited to the address space, which on 32-bit is 4 gig, and then you're further limited in the sense that Windows will take some of it for Windows stuff, which is that kernel mode stuff. And over time, the balance there has shifted a little because it used to be just, I think, a 2-2 split. Between user and kernel, and it moved more now, so you can request more. And there was even, like a PE extension. There's a whole specific set of stuff to allow more memory stuffing in 32-bit. But realistically, if 64-bit, you could use, I don't know what 2 to 64 is actually, top of my head, but someone with some math and a calculator can do that. It's surely in the trillions.
Yeah, we're not going to get there in this decade, right? It's pretty far out.
No.
No. Yeah, so it's not like we're doing 64-bit and then we're changing to 128-bit like 2 years from now.
Yeah, I don't think those 128 chips are going to be a thing for a long while. Maybe we'll move to quantum computing and get to use qubits.
Now,
which will be
now
fun.
We're talking.
No, I don't think this is an application for quantum computing.
We're gonna rewrite VS from C# into Q, the language Q, right? Isn't that what they call it?
Yeah, that's the .NET. Yeah, quantum Q. Yeah.
Here's a really good one. I was just thinking about asking you a similar one here. What about running 2022 from an external SSD? Right, whether it's external or internal, I guess. I don't know.
The key thing is the write speed and the random access speed. And so I don't know if you for example, if you put that over a USB 1.1 connection, I'd say that's a terrible idea. Like in connecting SSD over such a slow USB would be a very, very bad thing for everybody to do. I don't know off the top of my head what the limits of 3.0, USB 3.0 are versus external. I assume you mean a USB connection. If it's something else, then whatever that connection speed is. But in general, I think one of the best investments for performance of VS is an SSD, and if you get to use a fancy computer, an MM2, the new solid state, MN, the new, much closer on motherboard solid state drives.
So what?
And then
I think I remember something about like that the SSD was more important that it was on the OS drive, the system drive, instead of it being on the drive that you have Visual Studio installed. Is that true?
So like if you're splitting where VS is installed, the files, where your source code matters is the biggest thing. Like, yes, loading the Visual Studio binaries into memory can be slow, but in general, like depending on your application, your source code is going to be where you're doing find operations and where you're doing go to operations and stuff like that, and build operations clearly. And so, that's reading across, reading those in is probably where your perfit is. Like once you've loaded Visual Studio, like by and large, the binaries that Visual Studio represents are loaded in memory. Obviously, as you do more scenarios, they can get paged in. But I would suspect the benefit is having your code on the fast drive.
Okay. And
NVMe, that's it.
NVMe, yeah. There we go.
Thank you.
A lot of people are chiming in here.
I got one of those recently. It's so sweet.
Yes. So that's currently the fastest. And we've been telling people for quite a few years that like the number one thing you can do for Visual Studio Performance is to go from spinning Rust to SSD. And now it's even get on to the fastest SSD you can get, right?
Yeah.
What about memory? Like, is there, because I know there's different clock frequencies on RAM blocks. Is that big of an impact?
I don't think we ever got any data around like, maybe we should crunch this after, around like the performance, like DDR 300 or whatever it is today, like versus some other. I think the amount of RAM and reducing the paging that Windows does, the page faults. Essentially, like when Windows encounters something that isn't loaded into memory, it fires a page fault and goes fetches it from the disk or wherever else it's spinning. And so that's the impact. So like more memory reduces the occurrences of that, especially if you're using like VMs locally, which consume globs of memory. And they take it away from a lot of things, because depending on how you're allocating that VM's memory, it just might straight up allocate all of it from your RAM, or dynamic allocation, depending how you set it up.
Yeah.
So more memory, it's pretty cheap these days relatively to where it was, and so it doesn't hurt us or anyone else.
Good. All right. So okay. I think I'm representative for a part of the audience right now. I'm running Visual Studio off of a laptop. I got 16 gigs of memory. I don't code on or work on like these huge solutions. Like the blog post showed, loading a 1600 project solution with, was it 300,000 code files?
Yeah, 298,000 in total, but 300K, yeah.
It's just absolutely amazingly huge, right? Obviously, not that many people work on something that huge. And so if you're working on something that's like 20 projects in one solution, that's your main thing that you work on. Everything else is smaller. You're on a laptop, 16 gigs of memory, which is like, I think like all the Surface Lines laptops and Surface Books, and a lot of the Dell and HPs and all the other ones kind of follow that, or use the same sort of. Are we good? Are we going to get like a good utilization of our memory here? What if I want to run 3 instances of Visual Studio 2022?
Yeah, so that starts to become the challenge. It depends what you're doing at the same time. The contention for resources, obviously, both the CPU resources, just pure thread availability, as well as like memory availability and stuff like that. But those sort of, like, I forget what our minimum requirements and recommended requirements are, but like a reasonable laptop with SSD and 16 gig of RAM should just do fine. With a reasonable solution. Like, obviously lots of caveats, and there are some things that can greatly impact performance that are out of our control. So for example, some virus scanners may happen to open up files and scan them, so obviously that can have a huge impact on things like build time and open times and stuff. So some of those other things can be worth looking out for as well, in terms of might be impacting or your overall experience.
Yeah. Okay. So that sounds good. The you mentioned here, and we had a question up above, and I can't find it right now, but it was about solution load times.
Mm-hmm.
And of course, depending on your solution, how complex it is, how many projects there are, how many different types of projects, right? Are they all .NET class libraries, or are they like many different types? It can take very short time to load Visual Studio with a solution, or it can take longer, right?
Yeah.
Is that going to see a difference on 64-bit?
So to the 50th percentile, to be honest, I wouldn't imagine so. Like the 64-bit move is likely not to affect the bulk, like the 50th percentile. It's more likely to affect people at the further end, like certainly at the 95th and beyond, obviously, but people closer to that percentile range in terms of users. There's no way I can even like an exact, and perhaps we can see what data we can share, but like a lot of people use Visual Studio very lightly, if that makes sense. And so that, just single project even, and those people, those scenarios won't really be affected by this, hopefully. But it's definitely like the most benefit is to our most dedicated customers who tend to be further along in terms of percentiles.
Yeah,
Of, like,
so
where they
that
sit.
would be the ones that have like those huge solutions, for instance.
Yeah, and huge is relative. It doesn't need to be 1600 for sure. Huge is much lower than that.
Well, so that's I guess it's because the complexity plays a role, right? Because Visual Studio has to load all the different components that know how to handle a C++ project and a .NET class library and a WinForms project and an ASP.NET project and a Visual Studio extension and a Python and all those different things. And so many things have to be kind of loaded dynamically at runtime, and that takes a while, right?
Mm-hmm.
Now, if we can spend a lot more memory, like if people have 64-bit rigs or whatever, can't we like pre-hydrate the memory?
That's certainly something that I think people are going to consider more. Like a classic example of this is finding files, where one option you can have is you can index the entire directory and all the children in it ahead of time. So the first time you find the files is super fast, but you have to have this huge hit of parsing the entire directory, loading all those into some sort of index structure in memory. And maybe that's a trade you should make. Like, there's certainly some tools that work that way today, where you can have a finding files that's super fast, but it just took up 3 gigs of your memory. A lot of computing kind of sounds boring in like a computer science lesson. It's a trade between CPU and a trade between memory, time and space.
And I guess disk, right? Because initially that information is stored on disk. Now you have to move that into memory.
And depending on your availability of your RAM, that hopefully should be faster. Again, building the structure is often more important than the files. So you can say, like, look for foo, and you've got some fancy indexing technology to find foo, of which there's many ways to do indexes.
But I can imagine if you are on an 8 gig memory machine, you may not find that you have that much memory to spare for some stuff like this. But I see very often people have like these huge, like 64 gig. Like, could you imagine a future where we allow users to like say, yeah, I want to opt in based on my memory that I want to allocate to this for these type of
absolutely. I think that's one of the things, like, if you're working at a games company, you have a very large project and you have a sweet dev machine with all sorts of RAM, then that's exactly the sort of trade you might want to make. Like, screw it, like, just index everything, or other trades like that. And but that is like something to think about, to balance it with people who might not want that. So it is a bit of tricky. Perhaps we should have a little slider that says optimize for performance versus memory consumption, kind of like Windows does for battery life. But
that would be kind of interesting. Yeah, right.
Trade-off.
I never really think of it as a trade-off, but of course it is. I don't think a lot of people think of it as a trade-off, but you have finite resources and all your processes are competing for them all the time.
Yep.
Okay.
To go to some questions in the chat, I think someone will probably ask about WinUI. So kind of going back to the discussion we had about moving UI frameworks, it's not that simple. We have a lot of UI in Visual Studio. Like I mentioned, tools are HTML and JavaScript, and they clearly wouldn't be easy to port to WinUI. And if you did port them to WinUI, they'd just be hosting a WebView control, so it's not really porting. I think that's a much bigger question that will be tackled over a much longer time period than this release.
Okay. Here's an interesting question. I don't know if you know this. Have Microsoft tested this, I assume 64-bit Visual Studio 2022, on typical developer setups rather than our own like super duper computers running in a lab, super optimized?
Wait, we get super duper computers? I got a Surface Book too. Like, I don't even have 60 gig of RAM on that, to be honest, but I do on my desktop PC. Yes, we will test on a variety of hardware. Like, we have hardware for all sorts of scenarios, as well as data. Like, we, from taking part in the previews, obviously we collect telemetry around performance and things like that. And so hopefully with a broader set of people using it, we'll get telemetry and, help to how should we say, make sure that we're performing as we expect. Like our lab tests aren't really designed for like, how should we say, like real world scenario. They're more designed for regression testing. Like, hey, if we slow down something, so consistency is often prioritized over real world replication for lab tests.
I saw a question here about like CPU, like single threaded versus multi-core and all that sort of stuff. Do we have any recommendations, or are there any system requirements, or something that has to do maybe with 64-bit even, where we say, okay, Visual Studio can utilize up to 4 cores, but anything beyond that, you're not going to gain much, versus like get a higher performing.
Yeah,
four core. Is there anything there?
It's not something we've had any recommendations around, because it depends again, unfortunately, on your scenario. So some workloads parallelize really well, like build. You can do build at the same time as you can do, your language service or find files or something else. So I don't think we have any concrete recommendations. I mean, and as we talked about, by the virtue of VS going to separate processes, clearly that means we can utilize more threads, because each of those processes have to run in at least one separate thread, and so there's no hard and fast rule around like how many you have. And I think, especially with modern cores, there's so many that, I don't know if we do anything other than trust the OS in terms of the framework to manage the parallelization.
But I know Visual Studio does a lot of background threading stuff, so it seems like having a lot of available threads would be a good thing for responsiveness, at least.
I mean, more CPU. Yeah, I mean, in general, more resources equals more faster.
Yep. Okay.
That's very true.
Here's an interesting one. Will Visual Studio 2022 be able to utilize the GPU? I assume you mean here for compiling projects and so on.
Yeah, like I mean, maybe. I mean, it certainly does for some workloads, like rendering. But I don't know, I don't know if I don't know if things like MS Build or C++ compiler are actually suited to GPU. I wouldn't think so. But perhaps they are. So I think it'd be really up to individual components to decide what things they can offload. And obviously, rendering is the thing that gets offloaded today to GPU.
The WPF rendering of the UI itself.
Yeah, and even some of the browser scenarios depends. But other than that, it just depends on individual workloads. Like ML, for example, I'd imagine they offload stuff to GPU all the time. Well, at least I hope they would. I don't use CPU emulation, but I don't know.
So that's something we should talk to the individual component, like the Roslyn compiler or MS Build team or whatever. They might be able to shed some light on this. That seems like it would be an interesting thing.
Yeah. Especially since you're not playing a game at the same time as using VS, I hope. So perhaps your GPU is sitting there awfully idle and not getting you 60 frames per second in Fortnite or something, at 4K. So yeah, maybe that's a new title. I just don't know if the computation sets match.
No. Yeah. It is very interesting because a lot of laptops but also, of course, bigger rigs today have pretty powerful GPUs, right? Yeah. Even the onboard integrated chipsets and all that from the various manufacturers they're pretty significantly faster than they were not that long ago.
Yeah, help you mine your Bitcoins.
Yeah. Yeah, so that you might have a battery issue then at that point.
Yeah, certainly an energy hog. Yeah.
Okay, let's see here. We're tackling these questions they're just coming in here one at a time. We're going for it. Let's see here.
So that's the ARM one. I think that's come up a few times already. Oh yeah, there you go. Read my mind.
Is this the one?
Yeah, this is probably one of them. So today Visual Studio does not support running on ARM. And by support, that means we don't test it. And if you called into us and said hey, this doesn't work on my ARM device, we don't support it. And as of yet, we haven't announced any plans to change that in VS 2022. But a big thing to consider for ARM that's different for 64-bit is there's a whole ecosystem of stuff. 64-bit, as several people pointed out in the chat, is quite old, and almost everyone has moved to 64-bit. There's a whole ecosystem of dev tools, ecosystems of computers that exist. Whereas on the Windows side, even other platforms until recently, there wasn't such a large of desktop class devices for ARM, and even less so for developer tools on ARM and supporting stuff. You need your SQL Server to run, you need your IIS, you need all these other bits and bobs to run. Maybe you want WinRAR, etc. And for them all to move, it's not just a single thing. Hey, we've moved DevEnv to ARM, let's go quit. Mission accomplished. It's more about the entire ecosystem, and that's going to take time. And so we just don't have.
But if you were a developer doing .NET Core, or I guess .NET 5, we could say complete cross-platform only, then those are scenarios that would be then potentially supported in an ARM world?
So separately, you obviously, like .NET has separate support for ARM, and they publish that, and they have support for ARM, and the MVS can remotely target ARM devices. We've done that for many years now, and so you can connect your Surface device that's ARM based, or even another ARM based device, and you can remote debug, remote launch. The C++ team actually improved this experience recently to make it much easier to remote deployment.
Wow.
And so there's all sorts of great stuff that's coming to ARM. There's nothing to announce for Visual Studio. There is a DevCom ticket, and people should obviously vote on that. Because I think it's an interesting point. When does, we talked about like RAM and stuff, and but a lot of the Windows ARM devices aren't really equivalent to a lot of developer like desktops. Like if you have a desktop today, I bet you $1 that it probably outperforms your ARM device, which is targeted at consumers and extended battery life and things like that.
All right. Let's see here. We can at least get one more question in here. This is a good one. Are there any workloads available in 2019 that won't be included in 2022? Or in other words, are we deprecating features?
Yeah, so I think right now we don't have, we don't know, to be honest. Like we haven't shared and we haven't figured it out totally. But I'm sure like just across every version of Visual Studio major release, there'll be some things that we think it's best for customers to move on from. Because they don't represent a reasonable technology set for today. I probably just don't have that. I don't have that to share. To be honest, it's not because I'm hiding it from you like some sort of secret. I honestly don't know what entirely it is.
Okay. Here's one more from Matt. Will the new extensibility model be included in 2022 when it first releases, or will it come in later on?
So I think that's also in line with these like incremental improvements. The parts of it, like some of the out of process stuff, might be there. I don't have full details, and perhaps we should get Leslie on to talk about this in another office hours.
Yeah, it might be a little bit too early to know all the ins and outs of that as it is right now. Okay, I think. Oh, one more. I think I can answer this one. What about isolated shell support? So isolated shell, the last version available, and it's out there, is the 2015 version of isolated shell. That's the one that we make available for download. We're kind of gotten out of the shell business. We've decided that in order to provide the best features and for Visual Studio itself, we should concentrate there instead of creating shells for other people to put their features into. But it's available, and it's going to be available until Visual Studio 2015 runs out of support. So go grab it. There's absolutely nothing wrong with it. Okay. Do we have time for one more?
Sure.
Let's see here. Let's look. There's some that just came in. Oh yeah. I think we addressed like when is it coming, but will it also come for Mac?
Hey, we have a product for that. It's called VS for Mac.
Yeah, VS for Mac. Is that 64-bit? Will it be?
I don't know. I assume it is. But I don't know.
Yeah, all Mac is 64-bit, right? Yeah. So, okay.
They're very forceful in upgrading their ecosystem. So.
Do we know about Unity? Will there be better integration with Unity?
I honestly don't know.
Like right now, Unity is like it's an extension or it's a workload you can install it from the installer. I think, is that right?
Yep. It integrates with
Pretty sure that will continue to be there, right? That's
yes. And you can debug Unity, etc. I'm not too sure if there's what the improvements are. Sort of on the Unity, from the game side would be much better.
Okay. Andy, this is amazing. We got through the more comments than we've ever received on this show before, and I think we got to them all. So, and the hour is up. So thank you so much, everybody, for writing all the comments and engaging with us. That was fantastic. And if you haven't already, make sure to subscribe to the Visual Studio channel for more videos like this and tips and tricks and all sorts of other good things. And Andy, thank you so much for enlightening us on everything 64-bit.
Cool. You're always welcome. It's great to be here.
Good. All right. Until next time, everybody, take care.